Students, welcome to the science class. In last session, under the chapter of atoms and molecules, we discussed about what is a mole, isn't it? What is the types of the molecules? What is molecule? What are the types of the molecules? What is heteroatomic molecules? Isn't it? What is homoatomic molecules? And also, in last session, we discussed how we are going to name the compound. How we are going to name the compound, and also how we are going to symbolize an atom. How we are going to symbolize an atom based on IUPAC rules, and also we use some of the scientist theories. But today's session we are going to continue that lesson. We are going to study about in this session about chemical formulae. How we are going to write a chemical formulae, what are the rules to write the chemical formulae, and also we discuss here what is mole, what is molecular mass, what is mole, and how we are going to calculate the molecular mass. We shall discuss in this session. So first I am considering here chemical formulae. What is a chemical formulae? In last session we only studied how to write a symbol of an element of an atom here, but when we are going to consider a compound, for example water, I am taking water here an example, it is a compound. How we are going to write a water as a chemical formula like that? H2O. H2O, it is a chemical formula of water, but how we can write it? What is the rules behind that? Why we not write it as a OH2? Why we not write it as a OH2? Why we write only as a H2O? So that we shall discuss now. What is chemical formula here? It is a symbolic representation of the composition of a compound. You have to remember here what is chemical formula. Chemical formula, it is nothing but it is a symbolic representation of the composition of a compound. It is a symbolically represents how composition means how much amounts of the atoms present in a compound. It is a symbolically represents. We come to know from this chemical formulae, the an water molecule contains 2 atoms of the hydrogen, 1 atom of the oxygen, isn't it? It shows the chemical composition present in one molecule of an atom, one molecule of any compound. So what is chemical formulae? It is the symbolic representation of the composition of a compound. It shows, it gives us an idea how many atoms are present in that compound, what are the atoms present in that compound. We come to know from one example here, and a water molecule, it is a compound that contains 2 atoms, but we have to got an idea, or we are going to know about that by the chemical formulae. How it is possible? Because it shows it's a symbolic representation. How? So here the symbolic representation shows H2O. So we come to know from this the water molecule contains hydrogen atom and also oxygen atom. It represents the composition present in a compound. So what are the rules how to write a chemical formulae that we see here now? The first rule, the valency or charges on ions must be balanced. So when we are going to write a chemical formulae, we should balance the valency or charges present on an atom. So first you have to consider what is the valency of an atom. When we are going to write a chemical formula of a compound, we should know what is the valency of the atoms, and we should balance it. We should balance when we are going to write the chemical formula. After I will discuss how we are going to write the valencies. And second rule here, when a compound is formed by the metal and a non-metal, when a compound is formed by the metal and non-metal, symbol of metal comes first and then symbol of non-metal comes after onwards. So what is the second rule here? If a compound made by a metal or a non-metal, I am considering here NaCl, sodium chloride, it is a compound, it is made up of the 2, one it is a metal and a non-metal. So when we are going to write the chemical formula of a sodium chloride, we must write the symbol of the metal first. We have to remember when we are going to write the chemical formula of a compound which is made up of metal and non-metal, we should write the symbol of the metal first, and after onwards we should write the symbol of the non-metal. It is a rule of the writing of chemical formulae. Another one example I am taking here, copper oxide, because so copper it is also a metal and oxide, so it is a non-metal. When we are going to write any chemical formula of a compound, we should write when if the chemical formula contains or the compound contains metals and non-metals, we should first write the symbol of the metal. And third rule, what is the third rule here? When a polyatomic ions are used, so in a compound polyatomic ions are used, the ions enclosed in a brackets before writing the number to show the ratio. So if in a compound polyatomic, here we are considering only single atomic, we are not considering any polyatomic here. But when we considering the polyatomic, like I am taking one example here, calcium hydroxide. This hydroxide is a polyatom. So we are considering here a polyatom. When we are going to consider a polyatom, so first we have to write the polyatom in a bracket, and after onwards we should mention its ratio after the bracket. So that is the third rule, that is when polyatomic ions are used, the ions enclosed in the brackets, and the number shows after the ratio. So for example I am taking here the hydroxide ion, it is a polyatomic ion, we should write in a bracket and we should mention the ratio after onwards the bracket. Another one example I am taking here, NH4 twice SO4. So NH4, that is the ammonia, that is NH4, it is a polyatomic. Here we should write it in a bracket and we should mention the ratio after onwards the bracket, and we have to write other elements. So that is the third rule of writing a chemical formulae. Next I am considering another one rule here. We first write the symbols of the elements which compound is formed or the compound formed. So first we have to write the symbols of the elements which form a compound. So first I am considering one example here, water. So we have to first write the symbols of the elements. H2O I am considering here, water. Symbols of the elements, water contains hydrogen and oxygen, so we have to write first symbols of the elements present in a compound. Second rule, below the symbols of each element we should write their valencies. We have to write the valencies below the symbols which we are write. So valency of the hydrogen is 1, valency of the oxygen is 2. First we have to write, before writing a chemical formulae of a compound, we have to first write the symbols of the atoms which the compound contains. That is, the water contains here hydrogen and oxygen atoms, so I am writing the symbol of hydrogen as H and I am writing the symbol of oxygen as O. And second step, we have to write the valencies of the atoms. The valency of the hydrogen atom is 1 and the valency of the oxygen atom is 2. Next, see the second step. Now cross over the valencies of the combining atoms. We have to cross over the valencies of the combining atoms. Valencies of the combining atoms. And fourth step, with the first atom we write the valency of a second atom. With the first atom we write the valency of the second atom. With the first atom we write the valency of the second atom, and with the second atom we write the valency of the first atom. So these are the very important rules when we are going to write a chemical formulae. What are we first write the symbols of the elements. I am considering here water as an example. Water contains 2 atoms, that are hydrogen and oxygen atom, 2 types of atoms. So I am writing H as the symbol of hydrogen atom and O is the symbol of oxygen atom. So first step here we have to write the symbols of the atoms. After onwards, second step, we write the valencies of the respective atoms below the symbol. So I write here the valency of the hydrogen as a 1 and the valency of the oxygen as a 2. And third step here, we have to cross we have to cross the valencies of the atoms, and after onwards the fourth step we have to write the valency of the second atom. We have to write the valency of the second atom with the first atom, and we have to write the valency of the first atom with the second atom. That is, this is the chemical formula of the water. This is the way how we are going to write a chemical formula of a compound. Now I am considering under one example here, the carbon dioxide, how we are going to write the chemical formula of the carbon dioxide. So carbon, as we know already, carbon dioxide, the name says that the carbon dioxide contains two atoms, two types of the atoms. One is the carbon, another one is the oxygen. So the first step of the chemical formula how we are going to write here is, that is, we have to write the symbols of the atom. The symbol of the carbon is C, the symbol of the oxygen is O, isn't it? First step it is, we have to write the symbols of the atoms. That is, the symbol of the carbon is C, the symbol of the oxygen is O. Next step, we have to write the valencies. We have to remember, always we have to remember some of the valencies of the some of the elements, because it is useful to calculate molecular mass, and also it is useful to write the chemical formulas. So you have to remember, you have to practice the valencies of the sum of the elements. Now I am considering here the valency of the carbon is 4. Valency of the carbon is 4 and valency of the oxygen is 2. This is the second step, isn't it? It is the second step which we are going to follow when we are going to write the chemical formulae. Now we have to cross the valencies of the atoms. We have to cross the valencies of the atoms, isn't it? So the last step what it is, we have to write the valency of a second atom with the first atom. Valency of the second atom with the first atom, that is C2. And we have to write the valency of the first atom with the second atom, C2O4. So it implies us, see here we get the chemical formula of the carbon dioxide as a C2O4, but we have to consider here, that is, we can take 2 as a common. So we have to take 2 as outside, we get CO2. This is the chemical formula of the carbon dioxide. So it is the steps how we are going to, it is the steps involved or steps we follow how we are going to write a formula, chemical formula of a given compound. You have to remember these steps. Now I am consider another one most important concept here, that is nothing but the molecular mass. What is molecular mass? See, it is the sum of the atomic masses of atoms present in a molecule. So what is molecular mass here? It is the sum of the atomic masses. We have already know that what is atomic mass. So it is the sum of the atomic masses of atoms present in a molecule. I am considering H2O as an example. So what is the molecular mass of the H2O? So how we are going to calculate here? So consider the example that molecular mass of the H2O, how we are going to calculate? So atomic mass of hydrogen into number of atoms. The definition of the molecular mass itself says that it is the sum of the atomic masses present in a molecule. Is it clear? It is the sum of the atomic masses of the atoms present in a molecule. The water molecule contains 2 atoms, that is hydrogen and oxygen. So the sum of the atomic masses of the hydrogen and atom, it is nothing but the molecular mass of the water. So how we are going to calculate? See here, atomic mass of the hydrogen into number of atoms. Atomic mass of the hydrogen into number of atoms plus atomic mass of the oxygen into number of atoms of O, that is number of atoms of oxygen. In the water molecule, so 2 hydrogen atoms are present and 1 oxygen atom is present. So we have to write here the atomic mass of the hydrogen, it is 1, and the number of atoms present in a water molecule is 2, and plus the atomic mass of the oxygen is 16 into the number of atoms present in a water molecule, it is 1. So 1 into 2, that is 2, plus 16 into 1, that is 16. 16 plus 2, that is equal to 18. 18 units is the molecular mass of the water. So how we are going to calculate the molecular mass? That is, it is the sum of the atomic masses of the atoms present in a molecule. By using this theory, we are going to calculate easily the molecular masses of the compound. You have to practice taking some of the examples like a carbon dioxide, isn't it, H2SO4, that is sulfuric acid, HCl, that is hydrochloric acid, like that. You have to take examples and you have to, using the atomic masses, you have to calculate the molecular masses in your home. Now I am considering another one important, most important concept here, that is the mole. So see here, when we are going to buy the bananas from the market, we are going to use one word to buy some of the bananas. For example, I am considering 12 bananas. For 12 bananas, we are going to say it as a 1 dozen, isn't it? For example, we are buying some 12 bananas, we are going to call it as a group of bananas. For as a dozen we are using. If it is 6 bananas are present, 6 bananas we are going to buy, then it is called it as a half dozen. Like that, when we are going to consider the sum of the number of the atoms, we are going to represent a mole. That will be called by a special word, that is Avogadro number. When we are going to call the 12 bananas as a dozen, like that, if a mole contains, if the atoms present in a 6.023 into 10 raised to 23 atoms, if the group of atoms or the group of particles of the group of ions contains 6.023 into 10 raised to 23 atoms, then we are going to call it as 1 mole. And this 6.023 into 10 raised to 23, it is nothing but than Avogadro number. So if a group of atoms contains 6.023 into 10 raised to 23 atoms, then it is called it as a 1 mole. How we are going to call it as a dozen? That is, if a group of banana contains 12 bananas, then we are going to call it as 1 dozen. Like that, if the group of the atoms contains 6.023 into 10 raised to 23 atoms, then we are going to call it as 1 mole. So that is what is mole here. Mole, it is nothing but a group of Avogadro number of particles or atoms or ions called a mole. A group of Avogadro number. What is Avogadro number here? You have to remember the Avogadro number. It is a constant, that is nothing but 6.023 into 10 raised to 23. Avogadro, it is a name of a scientist which first time says which first time refers the number group of the atoms, that is which first time says the mole concept. So what is mole here? A group of Avogadro numbers of particles or atoms or ions is called it as a 1 mole. If a group of atoms, that is if one group which contains 6.023 into 10 raised to 23 numbers of atoms, then that group, it is called it as a 1 mole. You have to remember here, it is very clear that if a group of banana contains 12 bananas, then we are going to call it as a 1 dozen. Like that, if a group of an atoms contains 6.023 into 10 raised to 23 atoms, then it is called it as a 1 mole. Is it clear? So what is mole here? It is a group of Avogadro number of particles or atoms or ions is called it as a 1 mole. So now I am considering another one important concept here, that is nothing but molar mass. What is molar mass? It is representation of an atomic mass in terms of molar mass. We already know the atomic mass of any atom, but what is molar mass here? We have to represent that atomic mass in terms of molar mass. So molar mass, it is nothing but representation of atomic mass in terms of the molar mass. For example, the atomic mass of the hydrogen is 1 units. So the molar mass of the hydrogen, it is 1 gram per mole. 1 gram per mole. That is, we are going to represent the atomic mass in terms of the molar mass. That is, the molar mass of the hydrogen is 1 gram per mole. The atomic mass of the oxygen is 16 units. Then the molar mass of the oxygen is 16 gram per mole. 16 gram per mole. That is representation of the atomic mass in terms of molar mass. It is nothing but molar mass. Yes. Now I am discussing some of the important formulas to find out the problems which are comes in this lesson. That is, first formula, that is number of moles present in a given mass of the element. If they are going to ask how many number of moles are present in a given mass of the compound, that is number of moles present in a given mass of the element, that can be calculated by using this formula, that is number of moles present in a given mass of the element equal to given mass divided by molar mass, that is N is equal to given mass, it is nothing but the small m, and the molar mass, it is capital M. Using this formula we are going to calculate the number of moles present in a given mass of the compound. If they are going to give, I am taking one example here, if they are going to give 56 grams of the hydrogen contains how many moles of hydrogen, they are going to ask how many moles are present in a 56 gram of the hydrogen. So in that time we are going to calculate the moles of hydrogen atoms present in 56 gram of the hydrogen. Second one here, the second formula, number of moles present in a given number of atoms. If they are going to give number of atoms, they are going to, in the first example they are going to give the mass of the compound or the mass of the element, they are going to give exactly mass of the compound, 56 gram, 55 gram mass of the compound. But in the second case they are going to give number of atoms, they are going to give how many number of atoms are present. Using number of atoms, how many moles are present, we are going to calculate using this formula, that is number of moles present in a given number of atoms is equal to given number of particles, how many atoms are given, divided by Avogadro number, that is given number of particles, that is nothing but N, divided by Avogadro number is represented by N naught. So you know already Avogadro number is nothing but 6.023 into 10 raised to 23. By putting the values we get the required answer. And third important formula here, mass of the given mole of substance, mass of the given mole of substance. If they are going to give 3 moles of oxygen, if they are going to give 4 moles of oxygen, what is the mass of that 3 moles of oxygen, that can be calculated by using this formula, that is mass of given mole of substance is equal to molar mass into number of moles, molar mass into number of moles, that is mass, small mass, the given mass of the substance, that is small m, is equal to molar mass is represented by capital M, and N, it is the number of moles, small n represents the number of moles. Yes, it is, if the question comes like that, what is the mass of the oxygen, if the oxygen number of oxygen moles, that is 6, what is the mass of the oxygen if we are going to consider 6 moles of the oxygen. Is it clear? So we have to calculate the mass of the oxygen by the given number of moles of oxygen. Next, another one important formula, that is number of atoms in a given mass. If they are going to give the mass of the atoms, if they are going to give 36 grams of the oxygen, how many atoms are present, number of atoms in a given mass, they are going to give gram of the any mass of the any element, like 60 grams of the oxygen, 60 grams of the hydrogen, 90 grams of the oxygen. But how many atoms are present in a 60 grams of the oxygen, how many oxygen atoms present in a 90 gram of the oxygen, that can be calculated by this formula, that is number of atoms in a given mass, that is capital N is equal to given mass divided by molar mass, that is given mass, it is nothing but, I am taking one example here, 60 gram divided by molar mass. We have to calculate the molar mass by using the atomic mass of the oxygen. Atomic mass of the oxygen is 16 gram, so molar mass, it is nothing but 16 gram per mole into Avogadro number. Avogadro number, it is nothing but 6.02 into 10 raised to 23. By putting the values we get number of atoms present in 60 gram of the oxygen. So another one important formula here, percentage of any given atom in a given compound. If they are going to ask what is the percentage of the specific element present in a compound, I am taking one example here, H2O. If they are going to ask what is the percentage of the hydrogen in a water molecule, then we are going to calculate using this formula, that is percentage of any atom in a given compound is equal to mass of the element. We have to write down the which element they are asked, which percentage of which element they are asked, we have to write the mass of that element divided by mass of the compound. We have to write the mass of the compound into 100. By putting the values here, we can get the percentage of any given atom in a given compound. So now I am considering one example here. Calculate the number of moles present in 50 gram of helium. What they are asked? The number of moles present in 50 gram of helium. They give the mass of the element here, mass of the atom they are giving, mass of the element here they are giving. They ask how many number of moles present in 50 gram of helium. See, that is they ask number of moles. The number of moles asked here. First we have to write down given, that is mass of element, that is m is equal to how much it is, 52 gram, isn't it? And we know that atomic mass of helium, atomic mass of helium that is 4 units. Then molar mass of helium, that is capital M is equal to 4 grams per mole. 4 grams per mole. But what they are asked here, asked number of moles present in 52 gram of helium. Asked number of moles is equal to what? So what is the formula here to find out the number of moles? Number of moles present in a given mass of the element, that is given mass divided by molar mass. So that is number of moles present in a given mass of element, that is N is equal to, the formula is given mass divided by molar mass. That is equal to, given mass here, the given mass is 52 gram, and the molar mass is 4 gram. So they don't give the molar mass here. We have to calculate the molar mass by knowing the atomic mass. They give the helium as an element here. The atomic, we know that atomic mass of the helium is 4 units. Then the representation of the atomic mass in terms of the molar mass, that is nothing but molar mass of the helium is 4 gram per mole. So we have to remember here, in any question they don't give the molar mass. We have to calculate by using its atomic mass. So molar mass of the helium is 4 gram per mole. So therefore 4 ones are, that is 4 ones are 4, remaining 2, that is 12, 4 3s are, that is equal to 13. N is equal to 13. So therefore in the 52 grams of the helium, the 52 grams of the helium contains 13 moles of the helium. Is it clear? So it is clear, by using these all formula we can calculate some of the problems comes like this in this chapter. So you have to practice, you have to calculate the problems which are given in chapter atoms and molecules by using these are all formulas, and these type of examples comes in your examination for 2 to 3 marks. You have to concentrate on this. So, and this completes your another one important lesson, that is atoms and a molecule. So in the next session we are going to study another one new lesson. Thank you.